So in this video we're going to take a look at our right angle triangles. We'll solve them for an unknown side length. Now you will have learned how to handle that already if you already have the other two side lengths through your Pythagorean theorem or your sum of squares. But here we'll be working from an angle and another known side length. So in order to follow along with this lesson, you'll need to make sure you are comfortable working down. You'll need to make sure you're comfortable solving an equation using inverse operations. That is, recognizing that multiplication and division are inverse operations, that addition and subtraction are inverse operations, and we'll get a new inverse operation next lesson. And you'll also need to be able to handle calculating trig ratios, and that is from using a calculator, calculating the sine of an angle, the cosine of an angle, or the tangent of an angle. You'll see that as we get through. That is either through using a calculator or through using a trig table. Now we'll start off. We have ourselves a right triangle right here. Now when we're labeling a right triangle, we always label it using the same three words. Directly opposite of that right angle is always going to be the longest side of your triangle. We call that a hypotenuse. Now from here, we'll always need to work with some kind of an angle, whether our lower angle is known or our upper angle is known. You might have an angle theta in there, or you might have a numerical value in there, let's say 22 degrees right here. Now from this angle, we need this angle to label our other two sides. They are adjacent, which means beside, and so our adjacent side is beside that angle, and our opposite side is opposite of that angle. Nice and easy. So what I want you to do is I want you to take a look at this triangle right beside us right here. I want you to pause the video. I want you to label, let's label up here this time. We'll label 71 degrees right here, and I want you to pause the video, label all three sides. Good, so nice and easy. We see our right angle right here, directly opposite that always is our hypotenuse. Directly opposite the labeled angle is our opposite side, and adjacent to beside our labeled angle is our adjacent side. Nice and easy. So we'll use those skills, and we will use the phrase SOH CAH TOA in order to choose an equation that we're using right here. Now, as it works, we're always going to look, you'll notice within this phrase SOH CAH TOA, you'll notice that the second two letters of each section are made up of an O or an H or an A, or rather a combination of two of those. So we're going to choose, whenever we're working with a triangle, we'll be using an equation from SOH, or we'll be using an equation from CAH or from TOA, depending on which sides we're working with. So let's work right here. Remember, we're using SOH CAH TOA, SOHCAH TOA. And from here, we're going to start off by labeling what we have. I encourage you to pause the video and come back to see how we're labeling our triangle here. Directly opposite our right angle, we have our side length 12, that is our hypotenuse. Directly opposite our 40-degree angle, we have side length x, that's unknown. We'll label that with opposite. And then down here, adjacent to 40 degrees, we don't have any information here. We neither have an x nor a 12. So we're going to label it, sure, but then we'll quickly cross it out. We don't have an adjacent side. We cannot rely on an adjacent side. So if that's the case, we're working with an opposite side and a hypotenuse. So let's take a look up here. Our TOA, which would give us the equation, the tangent of an angle equals the opposite over adjacent, where the T brings us tangent, where the O brings us opposite, and where the A brings us adjacent. Now, we don't have an adjacent side, so we're not able to use our tangent ratio. Good try. Let's try our CAH, C-A-H, that is our cosine of an angle, is equal to our adjacent side over hypotenuse. We cannot use this cosine equation because we have no adjacent side. We're not ready for it. That will leave our sine equation. Let's see how it works right here. The sine of an angle is going to be equal to our opposite over hypotenuse. Okay, does this rely on an adjacent side? No, it does not. So that means we've chosen an effective equation. Now from here, we're going to perform some substitution. We'll put in any values that we know of right away into this equation. Here we're using our working down skill. Our sine of an angle. What angle is that? That's our 40-degree angle that we're working with right here. So the sine of 40 degrees is equal to our opposite side, that is angle x, sorry, side length x, divided by our hypotenuse, that is 12. So now we've labeled our triangle so that we could choose an equation, and we've taken this equation and we have substituted in some values. We've done a fantastic job. We're almost through right here. All right, so the sine of 40 degrees equals x over 12. Well, the sine of 40 degrees, nice and easy here. There we are, the sine of 40 degrees, nice and easy. We just put that into our calculator. Now, depending on the way your calculator works, you might be typing 40 degrees in first and then hitting your sine button. My sine button shows up right here. That is the sine of 40 degrees is 0.64278766096. We don't need to copy this whole thing out. We will keep and round this to 4 decimal places. So 0.6428. 0.6428 is what we use. Easy. Now we have 0.6428 equals x over 12. We'll just bring that right down here. Remember, we're working down. If this part confuses you, you'll want to go back and review your working down skills. From here, we're performing our inverse operations. Sorry, we see this x over 12 right here. We want to get x on its own. So we'll need to undo this divided by 12. In order to do that, we multiply both sides by 12. Nice and easy. They cancel out on the right side, leaving us with 12 times 0.6428 on the left-hand side right here. And we find 7.71. So 7.71 equals x. There we are. What is that? What did we just find? That is our unknown side length that we were looking for. That's our x value right here. Now, there are a lot of steps there. There are plenty of opportunities for mistakes. I want you to try it out here for the variable on the bottom of the equation. The steps to solve will have one extra step involved that might be a little bit more complicated. So right now, I just want you to set it up. I want you to label your sides. I want you to choose an equation and substitute in your known values. I want you to come back in 5 seconds where I will have all of those done. Good, okay, so we label our sides. We don't have a hypotenuse, so we're not working with that. We're just working with adjacent and opposite. So if we use our SOH CAH TOA, the only equation over here that does not have a hypotenuse is our TOA. So we'll be working with the equation. The tangent of our angle equals the opposite over adjacent. Oops, nice and easy. So from here, we're substituting in the values we know. We know we're working with the tangent of what's our angle this time, 34 degrees. We know we're working with our opposite side, that's 9, and our adjacent side, that's x. That's our unknown value. We won't have our extra challenge just quite yet. First, we're going to evaluate this tangent of 34 degrees. We know how to do that using our calculator. So 34 degrees. This time we're not hitting our sine button, but this time we're hitting our tangent button. We end up with 0.6745. That happens to be a similar number to last time. Relatively close, but that's just a happenstance. So 0.6745, nice and easy, equals 9 over x. Now here is the part that is slight, that has an extra step before we can find our answer, because here our unknown, our x value, is in the denominator. If our x value is in the denominator, we'll need to get a little bit clever in order to work our way through. So right now we want x to be in a numerator. We want it to be on its own in a numerator. In order to handle that, we'll need to multiply both sides not by a number this time, but by an unknown number, a variable x. So we'll multiply both sides by x. It cancels out on the right-hand side. We're left with 9 on the right-hand side, and we're left with 0.6745 times x on the left-hand side. Now from here, we'll again perform an inverse operation. What's the opposite of multiplying by 0.6745? It's dividing by 0.6745. We'll perform that on both sides, 0.6745. Good, it cancels out on the left, leaving us with x equals 9 over 0.6745. 9 over 0.6745 according to our handy-dandy calculator. That tells us we're working with a value 13.3. that is our unknown side right here. Now you should, if you followed all of these steps, you should be able to handle finding an unknown side length using your SOH CAH TOA, whether there's a variable on top of the equation or a variable on the bottom of an equation. You should be able to handle the practice at this point. And if you kept up with us this whole time, ideally you can label your triangle, you can choose an equation, you can use that equation to find your unknown side length. Good luck.